So in this session at Group by, Brent Ozar, wait a minute, that's me, is going to be talking about availability groups at scale. So in this, a little bit about what I do kind of for a day job. I'm a consultant who does performance tuning and some high availability and disaster recovery type work. In the line of this, I get to work with a lot of different weird clients that are doing all kinds of strange stuff with Azure, Always On, Amazon Web Services, and Google Compute Engine is the newest one. So what I'm going to talk through is I'm going to talk through a fictitious set of business requirements. This is a blend from several different clients. There's something new that Microsoft is working on. I'm going to talk about that a little and why it's not such a good fit here. Then I'm going to introduce Netflix's Chaos Monkey and how that influences what we design. I'm going to talk about things that you have to look out for when you're going down this kind of complex road, and then sketch out a design for you that's an amalgam of several different clients kind of blended together into one. This doesn't represent one exact company. I'm mixing and matching pieces from a few different clients here to kind of protect both the innocent and the guilty. The things that you'll hear me describe are very similar to other real-world companies, so this is based nearly out of reality. We'll start with our business requirements. Let's say that we're working for an independent software vendor, somebody who makes an app, and this app has been out for years. This is not a new app. It's profitable. Lots of people use it. And they don't want to make as many changes as necessary in code. I hear a lot of people say, oh, you're going to move to the cloud, just rewrite everything so that it works for Azure SQL DB or whatever. Now here, they really want to stick with the code as pretty much identical as they possibly can. They have been hosting this application at customer sites. So like if a customer spends $50,000 or $100,000, they get to host it at their own SQL servers. Or the company also sometimes hosts some of these databases internally for customers. Now, none of the application requires Enterprise Edition features, but some shops do use Enterprise Edition just to get a large amount of CPU use or a large amount of memory. Now at this company, right now they have about 1,000 customers. The way that this application is designed, every customer gets its own database. For the database administrators out there in the crowd, I hear you sometimes cringing and going, oh my God, that design is horrible. You should never design it like that. Remember, the design is already shipped. This thing is profitable. No one wants to rewrite the app, and that has to keep working. They expect this thing to hit 5,000 databases within about 2 years. Right now, the average database size is only about 5 gigs. They expect it to get to, say, 50 gigs within 2 years. Because often as developers, we're starting to throw everything in the database. Oh, throw clicks in the database, throw every shopping cart experience in the database, just because it's easy. The database is a fun, safe place to start to destroy things, or start to save things. Destroy was totally a Freudian slip there. My max database size today is about 10 terabytes per client. And that's on the high-end side. They're expecting, though, a database to be of the size of 100 terabytes eventually, say within 2 years. And they're looking for fairly fast OLTP queries, small inserts, updates, and deletes, and they want their reports to start to get faster. This isn't one of those like Stack Overflow, performance is a feature, every query needs to be 50 milliseconds or less. When you run a big report scanning, say, 10 terabytes of data or 50 terabytes of data, today it takes at least 30 seconds. They would like it to be down closer to 10 seconds in the future. Now what's weird about this application, or more challenging, is it's very bursty. People will use it for, say, 3 weeks all of a sudden out of nowhere, and then they'll let it sit idle for several more weeks or months. Then they may jump in and beat the bejesus out of it again. I can't predict how much the databases are going to grow, and I can't predict when they're going to grow. Sometimes a new client will sign up with a credit card. People can sign up anytime that they want. And sometimes they won't load any data at all right away. And then sometimes they'll turn around and load, say, 100 gigs across the span of a weekend. To make things just a little bit more challenging, they don't have a whole lot of staff. If you've worked with an independent software vendor before, some of us have software apps on premises and we go, man, who wrote this thing? It's a steaming pile of dog poop. Don't they have a DBA on staff who could tell them how their query should run? The reality is most ISVs don't have a DBA on staff because database administrators are expensive. They like to sit around and not do anything and attend webinars instead of actually do real work. They do have, say, 30 help desk staff, and they have 3 full-time DBAs who have a little bit of clustering experience from the stuff that they've been hosting internally. Now, one day, the business draws everybody together, all of the IT staff, and they announce to everybody, we are done buying hardware for our on-premises data centers. We're simply over. We're not going to invest another dollar in our on-premises data centers. We have them, they work fine. We're just done investing in them. And within the next 12 to 24 months, we want to be 100% up in the cloud. We want to make as few changes as we possibly can to our existing applications. Whew. So you as a database administrator are now stuck with, how do you build an architecture for this? How do you build a bunch of SQL servers to pull this off? And I don't want to say money is no object, but I want you to think about just what would it take in order to pull this off. This is a surprisingly common request. There's a lot of companies these days who are saying, we're done with on-premises data centers, we're moving 100% to the cloud. I'm not saying they're right. This is the same thing that we ran into several years ago with virtualization. If you've been a DBA for a while, I bet you remember your management saying 3, 4, 5, maybe even longer years ago, we're done with these stupid physical servers. They suck. We're going to be 100% virtual. And sometimes it was a really rough initial journey. Today, you're probably mostly virtual by default. Maybe you still have a few physical servers. Well, they're cutting-edge companies making that same kind of decision today about the cloud. Microsoft hears this. And this is one of the things I like about Microsoft. When they hear money, when they hear customers going, I'm going to go do something and I don't care what it takes to do, and they're waving $100 bills around, Microsoft hears this and wants to take those $100 bills. They can't take them with Azure SQL DB because Azure SQL DB, while it's awesome and I'm a huge fan of it, it's fantastic, it doesn't work well for scenarios like this that we're about to describe when I have a mature app and I don't want to change the code, that I pretty much want it to work as is, and it's often leveraging features that aren't available yet in Azure SQL DB. I'll talk about what some of those features are here in a minute. So when Microsoft hears this, their upcoming answer for it is Azure SQL DB Managed Instances. This is a lot closer to the on-premises SQL Server that you already know and love. The difference is they're managing the high availability and disaster recovery instead of you. They don't specifically say, they announced this recently at the Build conference, they don't specifically say during the announcement that it's failover clustering or always on availability groups. And the fact that they don't say should kind of tell you that this is something that's a little bit different. This is the marketing slide that they used in order to announce it. They say that you should be able to migrate your fleet of on-premises SQL Server database instances up to the cloud with as little changes as possible. One of the second bullet point down there I find especially amusing, security isolation with Azure VNets. If you haven't used Azure before, this may seem like, what's this mumble jumble bunch of words? Well, this is as opposed to Azure SQL DB. If you want to expose Azure SQL DB to your customers, if you have customers who want to connect to your databases directly, like with Management Studio, with Azure SQL DB, you're going to be opening it up across the internet. You're going to have to define which IP addresses it's coming from or open this whole thing up to the internet. That doesn't gain a lot of friends. People don't get very excited about that. So what's really cool about this one is you can start to define more granular access rules and let people VPN in, for example, in to get access to your SQL Server. Lots of compatibility things that we don't have with Azure SQL DB. For example, SQL Server agent jobs. Woohoo! I don't know who's still asking for Profiler in the year 2017, but they're very excited about the fact that it's still compatible with SQL Profiler. I still use SQL Profiler. I'm just saying I don't know that I would let that determine where my databases live. If I wanted to move somewhere and it didn't support Profiler, I think I would put my big boy pants on and start to learn extended events. Database size is up to 35 terabytes. That's awesome. That's way beyond what Azure SQL DB handles. Native, now notice how the way that they say this, minimum downtime migration into managed instances by using native backup and restore and log shipping. So you're going to be able to do log shipping from on-premises up to managed instances. That at first sounds like it's a relief for me here. However, we in this fictional made-up company did not use this for two reasons. One is the pricing isn't out yet, and I don't know about you, but I don't go to the car dealer and sign up for whatever car they want to sell me without knowing what the price is. Knowing the price is kind of vaguely sort of important. The second part of that, though, is can't get the database's backups out and restore them into on-premises SQL Server. This is effectively a newer version of SQL Server. And if you've been working with SQL Server for a while, you may remember that we can't restore databases back to earlier versions of SQL Server. You can restore to newer versions, but you can't restore to older versions. So kind of like Azure SQL DB, this is one of those Hotel California clouds where you can check in. It's just really difficult to check out. You're going to be exporting all of your data, which is kind of tough when we start to talk about these larger databases where I want to get a transactionally consistent point in time. I am super excited about that thing that I just described there. It's awesome. It just isn't a good fit for me. So if I'm not going to be able to, use that directly, what am I going to be able to use? Let's start talking about the Netflix mentality. The Netflix mentality of managing stuff up in the cloud, they went 100% AWS years ago. And when they went 100% AWS years ago, they made a decision that you can't build reliable servers if your mentality as an administrator is that they're just only sometimes going to fail. If you believe that your servers are only sometimes going to fail, you're not really going to put a lot of work into protecting those servers. But what if I told you that every one of your servers will fail? Well, yeah, sure, Brent. I mean, I know that that's true, but no. What if I told you that you are going up against something that Netflix called the Simian Army? They built a suite of tools that do things like simply kill a VM that doesn't match their security standards. If they see you build a VM in AWS and it's not configured according to security best practices, they will delete it. They don't change the security configs. They don't email the owner to warn them. They delete it. They have the latency monkey. The latency monkey purposely injects latency into communications between two services so that when you're building something, you know that sometimes results are going to come back in 10 milliseconds, sometimes they're going to come back in 10 seconds. You have to build your app in a way that it will be resilient to that. That's terrifying for those of us who do things like mirroring or always-on availability groups. What about the bottom two? The chaos monkey will kill your VM dead, will delete it with no advance warning. Systems administrators at Netflix know that during working hours, any of their servers may simply disappear with no advanced warning. This really changes the way that you think about systems administration. When I know that every server I build will die, it will be viciously killed by the chaos monkey, and it's defenseless. There's nothing I can do to stop it. It's a ticking clock from the time that I build the server until the time when it eventually dies. This changes the way that I think about building a server because I know I will have to rebuild it from scratch. It's not a matter of if, it's a matter of when. I'm going to have to rebuild it from scratch and get it to exactly the same state. And realistically, I don't want to be in a meeting whenever one of my SQL servers gets deleted and get pulled out of a valuable meeting in order to go rebuild a server. If I'm going to deploy a SQL server from scratch, from scripting, installing all the objects, setting up the jobs, I want this whole thing to be done at the push of a button. I want, at the push of a button, the ability to deploy a new virtual machine, install SQL Server, configure it exactly the way that I want, restore the databases that I need, join it to the right availability group, and make sure that everything actually worked according to my specs. Imagine that if you had a button that you could just push, or more interestingly, a button that your scripts could push. What if you wire this up to the monitoring tool of your choice so that when it detects a problem with one of your SQL servers, it pushes that button and builds a replacement? This is a different way of thinking about systems management. In the cloud, there's a saying among systems administrators, you should treat your servers like cattle, not like pets. This is hard for us as database administrators because my servers are pets. They're handcrafted, loving things that I name very carefully. I grow very attached to the software that's installed on them, the way that I configure the master database. We think about, how do I configure TempDB? How do I set up trace flags? So I get a SQL server configured exactly the way that I want, and then if something happens to it, I try to save it. I put a practically unlimited amount of work into trying to bring this thing back from the dead. Insert pet cemetery joke here. In the cloud, with systems administration, you think about it totally differently. You expect your cattle to die, and then you put their skins on your car seats or whatever. The analogy only goes so far. There's a name for this career now: DevOps, site reliability engineering. These are groups of people who specialize in building this button, that they treat servers as code that they can repeatedly deploy. They check this stuff into change control. They build servers via scripts that they can test with another button. This has been a thing for quite a while for systems administrators. It just hasn't been a big thing for database administrators for a long time. Because usually when we think about database administration, we think that, oh, this is the most valuable server in the house. These things are precious, and we must make sure that they maintain exactly the way that they need to be. What if we could make them disposable? What if we could simply push a button and bring them back from the dead? Now, there are tricks with this. I'm going to talk about the major gotchas standing in the way of me treating my SQL servers as cattle. First off is when new databases are created. The way that we normally think of high availability and disaster recovery is we think of words like, I will set up log shipping, or I will set up always on availability groups. You don't have the time. What if anyone can add databases at any given time? I have to be able to protect them immediately with no human intervention. This is a problem for me here in this ISV, this software vendor's design pattern, where anyone can sign up with a credit card at any time, and my application is used to simply creating databases on the fly. One of two things is going to happen. Either I'm going to have to build in some kind of trigger that as soon as a database is created, it is automatically backed up, restored to another place, and joined into an availability group. Or I have to modify my application to do that, which is kind of off the table here. Or I have to have a grace period. What if I say initially that anything that gets created could be lost within 4 hours? If a client goes in and swipes their credit card, yeah, I'll capture the transaction, but whatever database got created for them, I may have a temporary window there where I may lose data. If the business says, that's not acceptable, you have to protect every database as soon as it is created, that just increases my costs a little there because I have to build much more robust automation. SQL Server doesn't have a lot of ways to automatically protect databases as soon as they're created. Next major gotcha is, what happens if I have cross-database transactions? Cross-database transactions are something that surprise a lot of people who use availability groups. They assume that they can do a begin tran, insert data across a couple of databases, and then commit the transaction. That works fine with always-on availability groups. It's just that it's not supported, because under some circumstances, when you fail over from one replica to another, one of your databases may have the change in it, while the other one does not. I'm not talking about sync versus async replicas either. We all kind of understand that with async replicas, if a database fails over, I may lose some stuff in one of the databases. Even in sync mode, there are scenarios where the transaction will commit in one database and not commit in the other and be seen as okay. I love how good Microsoft's getting with Books Online these days. They're getting really precise and detailed in the documentation. And this Books Online post, SQL 2016 and before, support for cross-database transactions within the same instance, has a beautiful explanation down at the bottom that goes into super detail about the scenarios in which this will happen. I have to get the business to read this with me and understand what the risks are, because this may rule out always-on availability groups if the business is super anal about not losing data. Next major gotcha is, do I have anything that's hard-coded inside this application that I'm working with? Do they have hard-coded database names? Do they have hard-coded global temp tables? What if they have a global temp table that all the users of the application use and it has exactly one name? Well, that's the same across all sessions. And if I try to put, say, 5 clients on the same server, they will all see the same global temp table. Same thing with agent jobs, login names. If any of these is hard-coded, I'm screwed. Last thing that's kind of a big deal, well, second to last thing that's kind of a big deal is how far of old back versions do I have to be able to support? Do I have to be able to support the version of my app from, say, 5 years ago or 7 years ago? And if so, what version of SQL Server did that application require? If they tell me I have to support a version of SQL or of my application from 5 years ago and it was only compatible with SQL Server 2012, guess what? That's the version that I'm capped at. I may have to have one SQL Server 2012 cluster back out there, plus other versions of SQL Server to support the current versions of my app. Then the last major gotcha is, how bad do we hammer TempDB? SQL Server only has one TempDB. You can have multiple TempDB files, it's just that there's only one TempDB. And if my application brutally murders TempDB, then everyone is going to suffer equally. We run into the noisy neighbor problem. Say that I let my end users connect directly into SQL Server and they have a habit of creating temp tables and dumping huge amounts of stuff into them. Well, then one poorly behaved client can actually take everyone down. I can have one client that does a big old select into, fills up TempDB, grinding all my other things inside that instance to a halt. If that's a problem, then again, that's another major gotcha where I may have to peel out each client into its own separate SQL Server instance. Now, for the case of this sample client that we're going to design, we're going to assume that they don't have any of those major gotchas, that they don't have global temp tables, they don't have problems with cross-database transactions. We're able to pile multiple clients into the same SQL Server instance. So in order to do this, I'm going to show you a really simple version of the design first, then I'm going to show you a few more complex variations of it that give me better high availability, better performance, and easier patching. I'm going to start with 4 servers. I'm going to start with 4 servers, SQL 2016 A, B, C, and D. And notice that the data centers are staggered. I have one in US East, one in US Central, the next one in US East, and the next one in US Central. For the purposes of this initial discussion, it doesn't matter whether I'm using Azure, Amazon, Google Compute Engine, any of those. It also doesn't matter whether I'm using permanent storage or ephemeral. Let's just keep things simple and say that I have 4 VMs in 2 different places. What I'm going to do is I'm going to set up an always-on availability group across the first 2 boxes. SQL 2016A that's in US East, and SQL Server 2016B that's in US Central. Different data center. Now, that does mean that whenever I do an insert into the client A's database and he has to replicate synchronously over to US Central, it's going to be a long latency hop. It's going to take a long time for these inserts, updates, and deletes to happen. That's a business decision. If the business wants protection across multiple data centers, there's a cost for that if they don't want to lose data. If they are comfortable losing data, then this could be an async replica over here in US Central. It could be that every time we do an insert, update, or delete here, we have that asynchronously replicated across somewhere else. Don't get hung up on those details yet. That's an implementation detail that we can solve in our design later. Now I'm going to add another availability group. Now, the first one, this handled 3 of my clients. The primary was here, the secondary was here. Now I'm going to stack on another availability group, starting with SQL 2016B, and then his secondary is on SQL Server 2016C. So I have cross data center protection here as well, and then I can stack in another one and another one, basically round robining my availability groups across multiple SQL servers. In this design, I'm only using 2 replicas per AG. I'm using a primary and then a secondary. There's no rule that you couldn't do 3. There's no rule that you couldn't do these all in the same data center if you don't need cross data center capabilities. The idea here is a basic building block template that you can use and then extend it based on whatever your data center's needs are. I'm watching Slack too. I see that there haven't been any questions specific to this yet. If you guys have any questions, feel free to fire away. Hold on a second here. I'm going to put my dog back up on the chair. Eugene says, quick question. Go ahead. She really wants to leave the room really badly, and she's like, come on, I don't understand why you won't let me out. It's because you're allergic to things, and you're going to scratch yourself. I know how you are, little boy. He says, so they'd have to be, Eugene asks, so they'd have to be all in the same Windows cluster, right? So technically, for Windows, for always-on availability groups, for the longest time, 4 years, all of these had to be in the same Windows cluster. Starting with SQL Server 2016, they don't have to be in the same Windows cluster. You can use certificates to jump across domains and clusters. I've only seen one person do this, and I'm not advocating that you do this, but I have seen one person do it. I'll throw it up here because it's a good link. Madeira Data Always On Availability Groups. The guys at Madeira Data, who are Guy Glancer and Matan Youngman, who've actually been on GroupBuy before, they have a blog post here that if you search for it, says availability groups on SQL Server 2016. They're kind of burying the lead here. What's really important in this blog post is they're showing you how to do it without a domain or without the boxes being in the same cluster. So it's kind of cool. And it has like a 30-page long set of instructions along with screenshots as well. All right, so popping this deck back up. All right. So now I got this 4-node always-on availability group, or 4 replica, if you want to think of it that way, always-on availability group. Let's say that one of these nodes goes down. Let's say that SQL Server 2016B goes down. Oh, let me pop open to, I got to set my taskbar over here so that I can see your stack questions at the same time. Either that or you're going to see me alt-tabbing. There it goes. You're just, no, I can't have that. Here we go. All right, there it goes. So say the SQL Server 2016B goes down. At the moment that this thing goes down, When it goes down, AG1 is unaffected because AG1's primary keeps right on trucking. If these two replicas are synchronous, there's going to be a brief pause while transactions start to time out on the secondary. This simply switches into async mode. Whenever the sync secondary disappears, he goes into async mode basically automatically, continuing to accept inserts, updates, and deletes here. AG2, though, as far as his end users are concerned, we actually have an outage happening right now. The outage will be brief, but for a brief time, this AG2 is going to be unavailable until SQL Server corrects itself. SQL Server corrects itself by failing over that AG. If it's a sync, there's a big gotcha there. SQL Server will only automatically fail over in ways where you can't lose data. It won't automatically fail over to an async secondary. But if these two were sync, within a minute, it's going to automatically fail over the AG over to SQL 2016B or 2016C. However, when it does fail over here, now I'm going to be running without a parachute because now I don't have a secondary replica protecting me. Here's where the fifth box comes in. Now, I didn't show this earlier, but I have a fifth box called SQL 2016E. Now, maybe I've already built him ahead of time, or maybe I spin him up based on a time basis. If I want to save a little money, let's say, after SQL 2016B has been down for 5 minutes, I'm going to go spin up SQL 2016E. I need to spin him up in the right location. Notice that I have to pick the same US Central Data Center based on wherever the down replica is at. It needs to be at the right instance size, because imagine being an ISV with dozens or hundreds of these SQL servers. I have to know what the right default size to spin up is: 4 cores, 20 cores. What kind of storage should I have? How many managed disks should I use? How should they be configured together? How do you format the disks? Do you use a 64K NTFS allocation unit? Details like that. Then I have to apply the right patches. I have to have some kind of database that tracks for every cluster, for every replica, what level, what patch level should it be at. And it may not be the same patch level that B was at. Because as long as I'm standing up a new replica, why wouldn't I bring him up with the latest patches? Assuming, of course, that my application is certified to use whatever that patch level is. Then after that, I've got to restore my databases, join him to the cluster, join him into the right availability group, and set him up as the right role. In this example here, if I'm replacing B, which is dead, I need to stand him up, restore clients A through C and D through F, join him into an availability group. Now to clients A, B, and C, they don't even notice that this happened. They were running without a parachute. Running without a parachute is the wrong. I keep using that phrase, and it's going on a skywire without a net underneath, or jumping from a plane without a parachute. But how many clients really want to take their data and jump off a plane, right? I need a new analogy. Clients A, B, and C never noticed that this happened because their secondary was down. It just didn't matter. Their primary kept right on trucking. Clients D through F, they noticed it, but only for about 60 seconds until this thing failed over. Now that we have secondaries, these guys have parachutes again. Maybe they're just riding in the plane. They haven't jumped out yet. Maybe that's a better analogy. I'll have to work on that one. But now I have secondaries for them that are caught up to speed. I do not automatically fail over this AG to become primary over here, because that's an invasive operation that end users would notice. My whole goal here is to avoid any kind of end user notice. Joe says flying without parachutes. Yeah, that probably makes a little bit more sense there. Then, whenever I do have a maintenance window where I'm allowed to fail these over, and maybe if you're thinking at cloud scale, a maintenance window means I watch the databases, and if there's a 60-second gap with no end user queries, maybe I use that as my immediate maintenance window and I fail this guy over. Now, dun dun dun, I'm right back to the same original state that I had. It's just that one of my SQL servers has a slightly different name. In theory, you could stand up a server with the same name. I actually don't want to do that, because the problem is that SQL 2016b may come back up when I don't expect it. I may want to use some kind of PowerShell scripts to simply kill that guy or delete him at some point, but I want to prep that other SQL server even while SQL 2016b may be rebooting. All right, let's see if we have any questions so far. John says, you're jumping from the plane without a reserve. If your main messes up, oops. Daniel says AG2 has 2 primaries. Ooh, that's a great catch. So this should actually be secondary rather than primary. I got to get Daniel to typo or check more of my decks more often. So what am I going to do in order to accomplish this? The hard part of the plan is SQL 2016e. Building the servers the first time is not a big deal. But the thing is, I need SQL 2016e to come up automatically. I need some kind of registry of all the SQL servers that are out there, what databases they have, what patch levels they need to be on. And then I need a tool that's going to go read that registry and build the SQL server on the right whenever this kind of disaster strikes. And for me, I think that one of the big things is that last line on the slide there, test to make sure that everything worked. Some of you may have been sitting in Cody Conier's session this morning at Group I, where he talked about doing tests with Jenkins across all your SQL servers. And I bet a lot of us were taking notes in there going, oh, this sounds really interesting. It sounds kind of cool. Imagine that being a prerequisite requirement for every SQL server you build, a test that says, did you build it correctly? This is a lot of work. CVRIRL, I should click on his name so I can see what his exact name is. Vioral, okay, Vioral says, what are we doing until the databases are back into being in full sync? I prefer drinking, watching television. Air Disasters is one of my favorite shows. Project Runway is good as well. Survivor, I would usually recommend, but the Survivor season is over. Does it matter what I do until the databases are back in full sync? Jumping back a couple of slides, when 2016b is down and these guys are getting up to sync, I'm not doing anything. The application doesn't know that we're down. The application is still connecting up to the primary and doing things. But I love where you're going with that. You may want to elaborate more a little bit on what you mean by what are we doing. Although I would love to talk more about the drinking that I'm going to do when today is over. Woohoo! It's Friday. The biggest problem for me with this is, in mid-2017, this is an exercise that's left for the reader. It's easy for me to write a slide that says, all you have to do is build a registry of your servers and then build a tool that will deploy them according to whatever was in the registry. That's hard. That's seriously hard, let alone the testing. If you're a production database administrator, you should be aware of dbatools.io. This is an open source PowerShell kit with all kinds of commandlets. It was originally started, I want to say, by Chrissy Lemaire and Aaron Nelson. And they've been making production DBAs' lives way easier, but it doesn't have the stuff that I just described. I have faith that this kind of toolkit will get more advanced in, say, 2 to 3 years, where it can do the kinds of things that I just described. The problem is it's not there yet. We still have a long way to go before we're even remotely close to this. For right now, everything that I'm describing is mostly in the hands of very large companies with large DBA teams. VRL says, I was thinking about when the primary goes down, SQL Server automatically fails over. If you're in synchronous mode, the AG will automatically fail over to the secondary. If you're in async mode, we are waiting for you, the human being, to sober up, get to a keyboard, do your diagnostics, figure out how much data you're going to lose, and then ask someone with a C in their job title, like CEO, is it okay if we fail over this client and lose 37 minutes of data, or do we keep troubleshooting that broken replica first? So now that I got this stuff, this has a few interesting effects. First off is how I do patching. If I know that When I stand up SQL 2016E, he is fully patched. Say that instead of trying to stand up a replica that's an older patch level, like an older cumulative update or service pack, what if I stand him up to the most current cumulative update no matter what? If I know that the new replacement server is going to be stood up with the most recent version of SQL Server, I could simply get my server gun out or get the Chaos Monkey out and put a bullet in one of my replicas. And whenever his replacement comes up, he's fully patched. Now, I don't really want to do that live in production. I don't want to simply walk up to a SQL server and put a bullet in it. But instead, what if I could mark one for death? What if I could say, I'm not going to put a bullet in the SQL server yet, but he has an expiration date on, say, Thursday at 10 p.m. That replica is going to die. I want you, Mr. Script, to go build out his replacement. The difference is just that he hasn't failed yet. I'm kind of seeing the future as to when his death is. This changes everything for me as a database administrator. If I want to do patching, I simply set in my repository, here's the version number that I want my replacement patch to be at, and then I mark a replica for death. Then it'll be all stood up. I'll have a secondary all ready to go in the availability group, restoring the databases and keeping them all in sync, ready to go whenever we fail over. Same thing with if I want to change the VM size. What if I say, right now, all my replicas are 4 cores and 14 gigs of RAM, but I'm having all kinds of performance problems. I want to set the new default size to, say, 16 cores and 64 gigs of RAM. I can do that inside my repository and then mark everything for death, and when they are respawned with their new versions and their new replacements, they have the new default hardware size. What if you're having problems that you just can't figure out what the issue is? Man, I've been troubleshooting this dang replica for 3 hours and I can't get it to work right. I keep having all these issues. Why troubleshoot? When you get on the phone with Microsoft support, they like to say things like, have you applied the most recent patch levels? Have you tried rebooting? Have you tried turning it off and turning it back on again? Oh, I'll raise you. I'll see your request and I'll raise you. I'm going to delete that server. I'm going to build it from scratch using our normal build scripts and then just simply get rid of it. Thinking in terms of cattle, not pets. If the new server comes up and doesn't exhibit the problem, I'm done. Would I like to know what the root cause of every failure is? Sure, but ain't nobody got time for that. I want to move a little bit faster and more dynamically than that. And for me, that means simply blowing replicas away rather than trying to invest a lot of time in troubleshooting them. During one of Cody's session this morning, one of the attendees said, man, I don't know how a single DBA could go about triaging and troubleshooting and managing 100 or more SQL servers. Well, if you don't spend time troubleshooting, you can manage a lot more SQL servers. This is harder, not easier. Building these kinds of scripts is crazy hard. Me as a DBA, I am not building these scripts. I suck at PowerShell. Like I open up PowerShell, I'm like, how does this thing work again? There's a huge investment in being able to build stuff like this. It's just a different investment, not the same investment. Now I talked about managing patching. The next thing about it is managing risk. When I designed this initial design for you, I said that every availability group had one primary in, say, US East, and another replica, it's a secondary, in US Central, that's in a different data center. That may not be enough insurance for some folks. You may want more replicas, and this is just a business spending decision as to where you want to put your replicas, whether they're in the same data center for higher performance or different data center for lower performance but higher protection. I'm spending now in terms of performance, not just for licensing, but also capacity. And then I got to figure out where my SQL servers are going to live. I'm going to default to just 2 replicas, a primary and a secondary. But if the business wants to spend more, we can start having discussions about where those SQL servers should live, data residency laws as to whether or not they're allowed to leave the country, and then whether or not they're living next to each other or further apart. It kind of peeves me off how Microsoft keeps inventing its own terms for things. To me, region means a geographic area like Boston or Texas. But the other cloud providers have agreed on that, and inside a given region, they'll have different data centers, and they call data centers an availability zone or a zone. They don't directly call them data centers because these things are large enough, especially with Amazon, that they may encompass several data centers and not just one. So they call it an availability zone inside an area. Microsoft calls every one of their zones a region. This is why Microsoft says, we have more regions than anyone else. Sure you do, Junior, but just because yours are data centers, they're not really regions. When I look at these two, it's not that one's better than the other. They're just different terms. So you're going to see me as I go through slides. I use defaults for either Amazon or Google, not because they're better. They just use kind of more standard terminology there. When you talk about Amazon, they use terms like US East is a region, and then they have several availability zones inside US East. So if you want 2 SQL servers sitting next to each other for super low latency, they would be inside the same availability zone. That's just not really reliable because sooner or later availability zones fail. What you would want to do for high availability is you would want to put them at least in 2 different availability zones, one in one data center, one in the other data center. And then if you were ultra paranoid for things like disaster recovery, you think about a totally different region. Say you might have your primary in US East availability zone 1, your secondary in the second one, and then a third one over in, say, US East Ohio. It looks a little bit different with Microsoft. Microsoft says things like US East US 1 and East US 2. They don't let you pick more granular than that inside, say, East US. They start to deal with things like availability sets, which is just isolating VMs inside one individual data center. For example, let's say that I have Amazon and I want very high availability. I may want to put 2 of my replicas sitting in 2 different US East data centers, one in 1A, one in 1B. These are both synchronous secondaries. I have a primary and then a synchronous secondary here for this AG. I have a primary, then a synchronous secondary here in this AG. Sync secondaries can work pretty well inside the same region, but you generally don't want to write synchronously out to different regions. Here I would have a set of async secondaries out in another data center. Ella says, would you use an availability group for disaster recovery, or would you use it for workload balance? This is another one of those great business decisions. If you want to offload queries off to a secondary in another region, like one that's closer to the clients, you can. It's just a licensing thing, because then whenever end users start to query their databases, we're going to have to license those servers. Eugene says, where does the witness live? Yeah, cluster quorum generally uses either a file share witness or a shared disk witness. I usually want my witness closest to whatever I'm going to believe the primary should be. In this example here, if I have 2 replicas in US East and one in, this is US East 2 is over in Ohio, if I want to keep this guy being the primary in most cases, I would probably put the witness over here in US East 1A. There's an argument to be made to putting the witness in a totally different data center, like say US West, California. The problem with that is, sooner or later, US East 1A is going to lose its network connectivity for brief periods of time. Think milliseconds or seconds, not minutes. And I don't want to fail over just because I lost network connectivity for seconds. I want it to take a little bit longer than that. The last way that I deal with managing stuff in here is performance. When I'm dealing with the cloud, fast storage is really expensive. we're just this morning, a friend of mine and I were talking. He was commiserating about the slow storage that's available in Azure, and it's the same in Amazon and Google, unless you spend a spectacular amount of money. And the guy was like, my goodness, I look at the storage that's available for $1,000 a month, and it doesn't even match what I can get out of my laptop. My laptop here on the desk smokes the storage that I'm paying $1,000 a month for in the cloud. There's another option, and that other option is called ephemeral storage. This is throwaway local solid state space that's available for free in each of your VMs. The size of this ephemeral storage and the performance of it depends on your cloud provider. Generally, the numbers up here on the screen we're talking about for Azure. For Azure, you can get for persistent storage between 500 and 1,000 megabytes per second. But as soon as you go to ephemeral storage, you can go with 1,000 to 2,500 megabytes per second, and it's free. It doesn't cost you $1. There is a terrifying problem with it, which is whenever your VM reboots, this could be gone permanently. But as long as I'm thinking about cattle, not pets, as long as I'm thinking about any of my SQL servers being completely disposable, and as long as I'm covering these things with an availability group, and if the business wants to save money, this isn't the first thing that I go default to, it's just that if the business wants to save money, this is the kind of option that I can present to the business. Just saying that, if I reboot, say that SQL 2016E reboots, all of a sudden when he reboots, his databases are gone. Maybe I don't care about it if I have another secondary sitting somewhere else, and if that lets me get away with extremely fast storage that also happens to be extremely cheap. All of this are just different knobs that you can tweak when you start to design this. This general AG design, I don't need to design for local storage versus shared storage. That's an option I can set every single time I build a new cow, so to speak. Every time I generate a new cow from scratch, I can choose whether he's local ephemeral storage or whether he's shared permanent storage. The design is something that's reusable once you decide that you're going to do this cattle farming of standing up every single SQL server from code, not doing it with my friend from Spain, Manuel Labor. Manuel Labor goes off and builds his SQL servers by pointing and clicking through the GUI. In automation, we're trying to do all of this with code so that we can simply tweak the code and regenerate SQL servers in a new way. Now, as I start to describe some of this stuff in site reliability engineering, it sounds very different from what typical DBA jobs are. Site reliability engineers do all of this scripting with code and repeatable automation, checking things into source control. But today, that's not what most teams are doing. 99.999% of databases out there are still built the old school way by hand, lovingly handcrafting your database servers. But as you start to look further down the road, say in 2020, your SQL servers in the cloud are going to be much more common. But beyond that, that's where we start to even generate new VMs from scripts much more. You saw today, probably many of us for the first time, the Jenkins automated testing of SQL servers. That's still very much in its infancy. But now you start to see as that stuff like that becomes more common and deploying servers from scripts becomes more common, there are going to be new avenues of opportunity awaiting you out past the year 2020. I know, especially at the end of a day of a long learning set of sessions like this, and with Eugene's, you start to look at where am I going to make investments in my career? Should I be worried that my job is changing and I got to do all kinds of different things or things differently? Notice that you usually see presenters talking about new things that are out there. You don't need to know about them right away necessarily, but there are things that are going to open up for you in the future. If you're the kind of person who loves cleansing data, if you like getting involved with SSIS, reimagining tables, pulling garbage data out of tables, Data scientists need help with SSIS wrangling. That's a great career that's not going away. You see a lot of conference stuff that talks glowingly about how cool data science is or how cool analytics is. The quality of your data determines the quality of your output. Garbage in, garbage out. We've known that for decades. Well, that job is still getting stronger. So if you like cleansing data, that's a cool career. I hate cleansing data. That's my idea of hell, but other people may enjoy it. Cool. If you like building queries and visualizing data, you're going to hear a lot about R, about all kinds of analytics stuff coming forward. Python too as well with SQL Server 2016. That is a different career, just as SSIS data wrangling is a different career. That is a great career. There's a huge velocity and momentum going on inside of R, inside of Python, visualizing data. That will never go away. People always want to figure out what's going on inside their data and ask it new questions. I remember back when SQL Server 2008 came out, Microsoft was all, this is the year of BI, and it was. There were huge openings for reporting services, integration services, the analysis services. That's just as vibrant today as it was 10 years ago. If you like writing scripts and code, if the kind of building scripts and utility stuff that I just talked about appeals to you, then there's a huge career opening for that as well. Site reliability engineering, DevOps, these are cool new technologies. They're just different from database administration, just as SSIS wrangling is different, just as R and Python is different. It's nice to know where your options are at, what's available for you out there going forward in the future. But if you love what you're doing, if you love traditional database administration, there is still a solid career in that for at least the next 5 years. I just want you to know that there are roads that are opening up out there. It's not that you have to change the road that you're on today. All right, that's everything that I wanted to take care of out of this session. I will hold on here for a few minutes as y'all ask any questions that you like. I should throw a shout out to groupby.org. If you go to groupby.org, you can vote for the sessions that will be in September's lineup, and you can also see what's coming for next Friday's lineup. We have webcasts all day next Friday as well. Abo says, going back to managed instances, do you know if they will allow you to set compatibility mode? Literally, the stuff that was out there on the slide is the only thing that Microsoft has put out there like permanently so far. It's available for preview to large customers. If you want to go join the preview list, by all means you can go for it. The thing that's interesting with products that are in preview is they don't really commit to anything, and things can change as you get towards general availability date. They haven't ironed down the list of features, prices, or an availability date yet, so compat level, who knows? Ella asks, if you're using an availability group, could your application point to AG? Oh, let me reword her question a little bit. So if I've got 2 SQL servers in an availability group, can my application be writing data on this one while I'm changing the schema on this one, like doing a deployment script? No, unfortunately, only one of them will be writable at any given time. I do know of one shop where their application was 100% read-only. Everything that they did was read-only. And what they did was they let their application keep reading a readable replica, but they broke communication between the primary and the readable replica. They just made this guy readable, but did not let any updates flow through to him. Then they made all kinds of big application changes over on the primary. Their apps were still just read-only, pointing to the read-only replica. Well, they changed all kinds of things during a deployment script. If the deployment script broke, they threw away this replica, and this old guy became the primary. But as long as it worked, then they let communication go back through over to the readable replica, and then all of a sudden huge deployment script changes are happening underneath them. The size of the deployment script, of course, dictates how long that replication catch-up process will work. All right, thanks everybody for hanging out with us today. See you guys next week. Adios, everybody.